Let's work through an example of balancing chemical equations. This is exercise 1.6.6. Suppose we want to balance the following chemical equation. What does that mean? Well, that means we're looking for numbers, x1, x2, x3, and x4, so that the equation is balanced. So we can translate this into a linear system by counting the number of each atom, each element, right? So by looking at this, we see that we need 2 times x1, and that's going to equal x3 if this is going to be balanced. We also need 3 times x1 equals 2 times x4, and x2 has got to equal x4. Now, this is a linear system that's simple enough that we could just solve by hand, but since we're learning about augmented matrices and solving linear systems by Gaussian elimination, let's go ahead and set it up that way. So I line up the equations, line up the variables so that it's easy to see what the corresponding augmented matrix is, and it's this one given here. We do Gaussian elimination, and we get the following. I like to put squares around my pivots so that it makes it clear what everything is. And so the first 3 columns are pivot columns, and that tells us x1, x2, and x3 are basic variables. The fourth column is a non-pivot column, and so that tells us that x4 is a free variable. So we can write out the solution. X4 is some scalar t, it's free. X3 is 4/3 t, x2 is t, and x1 is 2/3 t. Now that's the solution to the linear system, but notice we want to solve this word problem. And so in particular, we want x1, x2, x3, and x4 to be positive integers. And so all we have to do is choose a value of t that makes that work. And so if we choose t equals 3, then we get x1 is 2, x2 is 3, x3 is 4, and x4 is 3. And so we have the following balanced chemical equation.